Welcome to the story of Maximus. It's Rivian's revolutionary in-house developed drive unit that's 40% more power dense than its predecessor, dramatically cheaper to manufacture, and designed to power three distinct powertrain configurations. These range from efficient and practical to absolutely, brutally supercar fast. This is the engineering story that's generating intense debate across Reddit forums, that Quora enthusiasts are dissecting in exhaustive technical threads, and that's driving massive spikes on Google Trends as more people discover something remarkable. Rivian might have just figured out how to make truly affordable performance electric vehicles without asking you to compromise on the things that actually matter. Before we explore those three powertrain options, before we talk about which one might be perfect for your life, we need to understand the revolutionary technology that makes all of them possible. We need to understand Maximus, the drive unit that changes everything. Developed entirely in-house at Rivian's facilities by engineers who weren't satisfied with what suppliers could offer, Maximus represents the third generation of Rivian's electric motor evolution. The company's journey started with origin motors sourced from Bosch, functional but not optimized for their specific needs. They progressed to the internally developed Enduro and Ascend units that power the R1 vehicles, learning invaluable lessons about what works and what could work better. Now, they've arrived at Maximus, the motor specifically engineered not just for performance, but for mass-market production at a scale Rivian has never attempted before. The centerpiece of Maximus's innovation is something called continuous winding stator technology. And to understand why this matters, you need to understand how traditional electric motors get built. In conventional designs, including Rivian's own Enduro motor, manufacturers use individual wire segments that must be inserted into the stator, positioned precisely, and then welded together at hundreds of connection points. Imagine trying to create a continuous electrical path through hundreds of separate pieces, each junction requiring a perfect weld. Each weld creates electrical resistance. Each weld generates heat that must be managed. Each weld requires quality control inspection. Each weld adds time to the assembly line. Each weld increases the probability that something, somewhere, will eventually fail. Maximus uses a continuous winding process that dramatically reduces these connection points from 264 welds per stator in the Enduro down to just 24 in Maximus. Think about what that actually means for a moment. That's a 91% reduction in welds. That's not just a cost reduction, though the manufacturing savings are substantial. It's a fundamental reliability improvement. Fewer welds mean fewer potential failure points over the life of the motor. Less resistance in the electrical path means less energy lost as heat. Improved thermal management means the motor can work harder for longer. Better quality control because there are far fewer points to inspect and validate. But the winding technology represents only one piece of Maximus's engineering brilliance. CEO RJ Scaringe, who regularly shares technical details on social media because he genuinely wants people to understand what his company is building, highlighted several other revolutionary aspects that separate Maximus from everything that came before it. Consider the inverter placement. In the Enduro motor, the inverter sits on top of the motor assembly. It's a conventional approach that works, but it's not optimal. Maximus positions the inverter on the side using the flat area at the end of the motor housing. Why does this matter? Because it minimizes the length of bus bars, those heavy copper or aluminum conductors that carry high current between the battery and the motor. Shorter bus bars means less weight. Less weight means better efficiency. Better efficiency means more range from the same battery pack. Every decision cascades into multiple benefits. The side-mounted inverter's large planar shape creates another opportunity. All the processing electronics and power electronics can exist on a single printed circuit board. Traditional designs scatter these components on multiple boards that must be connected, creating additional complexity and potential failure points. Maximus consolidates everything onto one board, dramatically reducing part count and manufacturing complexity. Fewer parts mean fewer things that can go wrong and faster assembly on the production line. The inverter chassis itself isn't just a protective housing, it's a masterclass in multifunctional design. This single component seals the oil-cooled motor cavity, provides a direct coolant path from power modules to the heat exchanger without requiring additional parts, and actually serves as the drive unit mount to the vehicle chassis, one part doing the work of 3 or 4. This is the kind of elegant engineering that separates truly innovative companies from those simply following industry conventions. Rivian's engineers integrated the front rotor shaft and gear into a single forged CNC milled component. Traditional designs use separate pieces bolted or pressed together, requiring additional bearings to manage the connections. The single-piece design reduces the number of required bearings and simplifies assembly, while improving reliability and reducing weight. The cumulative result of all these improvements: Henry Huang, Rivian's senior director for powertrain and thermal systems, confirms that Maximus achieves approximately 40% more power density than Enduro, while being significantly cheaper to manufacture. The company reports a 30% reduction in labor costs, an 11% reduction in engineered parts that must be designed, sourced, and assembled, and a 32% reduction in drive unit fasteners. If you've ever assembled something complex, you understand what a 32% reduction in fasteners means. That's 32% fewer bolts to torque to specification, 32% fewer potential loose connections, 32% faster assembly. But Rivian isn't just engineering Maximus, they're systematically torturing it. The company built its own in-house dynamometer testing facility, and in a brilliant example of vertical integration, they're using Enduro motors as the test equipment to validate Maximus motors. Recent testing included a month-long endurance run that would make most manufacturers nervous. They subjected Maximus to extreme low temperatures, where lubricants thicken and electrical systems strain. They blasted it with extreme high temperatures, where thermal management systems must work overtime. They simulated rainfall events to verify that seals hold and electronics remain protected. They cycled through these conditions repeatedly, looking for any weakness, any failure mode, any hint that Maximus wouldn't deliver reliable performance for years under the most demanding real-world conditions. This kind of comprehensive validation ensures that Maximus won't just work when it rolls off the assembly line. It'll work reliably when you're driving through a snowstorm 3 years from now. It'll work when you're climbing a mountain pass in summer heat 5 years from now. It'll work when you hit 150,000 miles and the vehicle has experienced countless thermal cycles, weather conditions, and driving scenarios. Now let's explore how this revolutionary drive unit powers 3 completely different vehicles, each designed for different lives, different priorities, different adventures. Let's start with the foundation of the R2 lineup, the configuration that enables that remarkable $45,000 starting price. The single-motor rear-wheel drive R2 features one Maximus drive unit mounted at the rear axle, driving the rear wheels through a carefully engineered gear reduction. This is the classic rear-wheel drive configuration that driving enthusiasts have loved for generations because it provides excellent weight distribution and balanced, predictable handling characteristics. While Rivian hasn't released official power figures yet, community speculation based on the company's motor sizing and the performance characteristics they've hinted at suggests the single-motor configuration likely produces somewhere around 300 to 350 horsepower. That might sound modest compared to the R2's more powerful siblings we'll discuss shortly, but remember something crucial. This is an electric motor. All that torque, Every pound-foot of it is available instantly from 0 RPM. There's no waiting for a turbocharger to spool up, no need to drop 2 gears to access power, no lag between your foot hitting the accelerator and the vehicle responding, just immediate, linear, relentless thrust. Here's where the single-motor configuration truly shines: efficiency. Electric motors are already dramatically more efficient than internal combustion engines, converting around 90% of electrical energy into mechanical motion, compared to gasoline engines that struggle to exceed 30% efficiency. But when you only need to power one motor instead of 2 or 3, when you're carrying less weight because you don't need additional drive units, when you're minimizing parasitic losses from extra drivetrains, efficiency improves even further. According to data that Reddit users extracted from a better route planner before some of the preliminary figures were adjusted, the single-motor R2 with the large battery pack could achieve over 300 miles of EPA-rated range. Some estimates suggest it might approach 320 to 330 miles in optimal configurations, with efficient driving and favorable conditions. This makes perfect engineering sense. With only one motor to power and the reduced weight that comes with a simpler drivetrain, the single-motor R2 maximizes every kilowatt-hour stored in that battery pack. The R2 will be available with 2 battery pack sizes, both using Rivian's new structural battery pack design with 4695 cylindrical cells supplied by LG Energy Solution. Based on CEO RJ Scaringe's detailed social media posts, each pack contains 3 large modules with 256 cells each, totaling 768 cells per pack. These are substantially larger cells than the 2170 format used in R1 vehicles, with approximately 6 times the capacity per cell. Fewer cells means fewer connections, simpler assembly, and lower cost per kilowatt-hour. Community estimates based on reverse engineering battery pack dimensions and cell specifications suggest the standard pack provides approximately 74 to 75 kilowatt-hours of usable capacity, while the large pack offers approximately 94 to 98 kilowatt-hours. With the single motor's efficiency advantage, even the standard pack should deliver well over 280 miles of range, making it genuinely practical for daily commuting and weekend trips. The large pack pushes that range above 300 miles, entering the territory where range anxiety becomes largely irrelevant for most driving scenarios. So who is the single-motor rear-wheel drive R2 actually for? Let's get specific about the lives and use cases where this configuration excels. If your daily commute is 60 miles or less round trip, you'll rarely need to charge anywhere except home. Plug in overnight, wake up to a full battery every morning, and never visit a gas station again. For urban and suburban commuters, this represents a fundamental shift in how you think about fueling your vehicle. No more detouring to gas stations, no more standing in the cold pumping fuel, no more exposure to fluctuating gas prices. If you're budget conscious but still want access to modern electric vehicle technology, the single-motor configuration will be your entry point at approximately $45,000. That's not cheap, but it's dramatically more affordable than most capable electric SUVs currently available. It brings Rivian's distinctive design language, their adventure-focused engineering philosophy, and that revolutionary Maximus drive unit into a price range that mainstream buyers can actually consider. If you're an efficiency enthusiast who obsesses over maximizing range per dollar spent, the single motor delivers the best possible efficiency from the R2 platform. You're not paying for motors you don't need, you're not carrying extra weight, and you're not powering additional drivetrains. Every efficiency optimization flows directly into extended range. For light off-road users who occasionally venture onto dirt roads, forest service roads, or mild trails, rear-wheel drive with proper all-terrain tires and the R2's 9.8 inches of ground clearance still handles these scenarios confidently. You won't have the same traction advantages as all-wheel drive configurations, but with proper technique and appropriate tire selection, you can still access the vast majority of campgrounds, trailheads, and scenic overlooks. For light towing, the R2's rear-wheel drive should handle small utility trailers, small boat trailers, and pop-up campers with ease. While Rivian hasn't released official towing capacity figures for the single motor yet, it's reasonable to expect a towing rating in the ballpark of 1,500 to 3,000 pounds. With careful packing technique and modest expectations, you can effectively pull a small camper for weekend getaways, haul a few bales of hay from the feed store, or transport a kayak or canoe to the lake. Don't mistake base model for slow. With instant electric torque and likely 0 to 60 times somewhere in the 5 to 6 second range, the single-motor R2 will feel genuinely quick in everyday driving. That's faster than the vast majority of gasoline vehicles currently on roads. Passing on highways happens with confidence. Merging into traffic requires no anxiety. The vehicle responds instantly to your inputs with the immediate throttle response that makes electric vehicles so satisfying to drive. The 115.6-inch wheelbase, adaptive suspension system, and substantial ground clearance mean this configuration will still handle rough roads, potholes, and imperfect surfaces with the confident, planted feel that characterizes good SUVs. It just won't have the same all-weather traction advantages and extreme performance capability of its all-wheel drive siblings. Step up to the dual motor and the R2 transforms from efficient commuter into capable adventure vehicle ready for genuine challenges. The dual-motor R2 features one Maximus drive unit at the front axle and one at the rear axle. This classic dual-motor all-wheel drive setup provides several crucial advantages that fundamentally change the vehicle's capabilities. First, you have continuous all-wheel traction. Both axles always have power available, instantly, with no delay for mechanical systems to engage. When the front wheels start to slip on snow or ice, the rear wheels are already providing traction. When you're climbing a loose dirt hill and the rear wheels are scrambling for grip, the front wheels are pulling you forward. This isn't the part-time all-wheel drive of many crossovers that primarily operates in front-wheel drive until slippage is detected. This is full-time, always-active, intelligent all-wheel drive. Second, you gain torque vectoring capability. The vehicle can vary power delivery between front and rear axles, optimizing traction and handling for current conditions. On a tight corner, it might send more power to the outside rear wheel to rotate the vehicle more aggressively. On a slippery surface, it might limit rear power to prevent oversteer while maximizing front traction for stable progress. These adjustments happen hundreds of times per second, faster than any human driver could react. Third, you get dramatically enhanced performance. With roughly double the power of the single-motor configuration, the dual-motor R2 likely produces somewhere in the 600 to 700 horsepower range. That's legitimate supercar territory from just a generation ago. A decade ago, achieving 600 horsepower required exotic engines, expensive materials, and careful maintenance. Now it's available in a practical electric SUV. Fourth, you gain substantially improved off-road capability. Power to all four wheels dramatically improves traction on loose surfaces like sand, gravel, mud, and snow. The ability to precisely control torque to each axle enables advanced off-road driving modes that optimize traction for specific terrain types. While official acceleration figures remain unannounced, the dual-motor configuration probably achieves 0 to 60 miles per hour somewhere in the 3.5 to 4.0 second range. That's genuinely fast by any objective measure. But here's what matters more for most buyers. That power is usable in real-world conditions where it actually improves your life. Consider your snowy morning commute. Four-wheel drive with instant torque modulation means you're pulling away from stoplights confidently while others are spinning wheels. You're climbing that steep hill to your neighborhood without anxiety. You're stopping more effectively because all four wheels can contribute to regenerative braking without overwhelming traction. Consider mountain passes. Power to pull grades without losing speed, to pass slower vehicles safely, to maintain highway speeds even when climbing thousands of feet. Electric motors don't lose power at altitude like gasoline engines do. That 600 horsepower at sea level remains 600 horsepower at 10,000 feet. Consider loaded vehicles, 5 passengers, their luggage, camping gear, bikes on the roof rack. The dual-motor configuration shrugs off these loads. The power is so abundant that weight barely affects performance. You're not struggling, not straining, just progressing confidently regardless of load. Consider highway merging and passing, effortless power at any speed. Need to pass 3 cars on a 2-lane highway? The dual-motor R2 gets you around them quickly and safely. Need to merge into fast-moving highway traffic? You're up to speed instantly with power to spare. The dual motor does sacrifice some range for its added capability, which is an unavoidable reality of physics. More motors consume more energy, particularly when you're actually using that additional power. Based on community estimates derived from ABRP data and Rivian's own range figures for similar vehicles, the dual-motor configuration likely achieves approximately 295 to 305 miles with the standard battery pack and approximately 340 to 360 miles with the large pack. That's still excellent range by any reasonable standard. The large pack with dual motors represents the sweet spot for many buyers. Serious capability without sacrificing practical range. You're still well above 300 miles in most driving conditions, which covers the vast majority of daily driving needs with range to spare. For longer trips, fast charging makes up the difference. Rivian hasn't fully detailed R2's trim levels and options packages yet, but the dual-motor configuration will almost certainly be the foundation for adventure-focused packages. Expect options like upgraded all-terrain tires with more aggressive tread patterns, roof rails and crossbars for carrying kayaks, bikes, or cargo boxes, enhanced underbody protection to shield critical components on rough trails, possibly additional ground clearance through modified suspension, and off-road specific drive modes that optimize traction control, throttle response, and stability systems for challenging terrain. The dual motor's ability to precisely control torque to each axle makes it ideal for challenging terrain where traction is limited or constantly changing. Hill descent control, which automatically maintains a slow, controlled speed on steep descents without requiring brake input, works more effectively with motors at both axles. Rock crawling modes that precisely meter power to maintain momentum without breaking traction benefit from independent front and rear motor control. Sand and snow modes that adjust power delivery to prevent wheel spin while maintaining forward progress become more sophisticated with 2 motors to manage. So who is the dual-motor all-wheel drive R2 actually for? Let's get specific again. If you're a 4-season driver dealing with snow, ice, wet leaves, or generally unpredictable weather conditions, the dual-motor configuration provides genuine peace of mind. You're not hoping you have enough traction, you know you have enough traction. You're not white-knuckling through winter storms, you're driving confidently because the vehicle is actively managing traction at all 4 wheels hundreds of times per second. If you're a weekend warrior who camps, skis, surfs, mountain bikes, or otherwise ventures off pavement regularly, the dual motor provides capability that matches your lifestyle. You can actually reach that remote campground. You can navigate that snowy mountain pass to the ski resort. You can handle that sandy beach access to the surf break. The vehicle isn't limiting your adventures. If you're a performance enthusiast who wants genuinely quick acceleration without going full supercar, the dual motor delivers satisfying thrust that makes every acceleration feel special. You're not compromising on performance to get practicality, you're getting both. If you're a family safety advocate who prioritizes all-weather traction and stability for your loved ones, the dual motor provides confidence that your family will get home safely regardless of conditions. You're not just hoping the weather cooperates, you're prepared for whatever conditions develop. The dual motor represents what Reddit discussions consistently identify as the Goldilocks configuration. Not too basic, not too extreme, but just right for the largest segment of potential buyers. It offers approximately 90% of the tri-motor's capability at likely 70% of the cost, with range that still comfortably exceeds 300 miles in the large pack configuration. For most people, most of the time, this is the configuration that makes the most sense. Now we enter the realm of the truly extraordinary, the configuration that Rivian executives have confirmed will achieve 0 to 60 miles per hour in well under 3 seconds, and that represents the absolute maximum of what the R2 platform can deliver. The tri-motor R2 features an asymmetric motor layout that's more sophisticated than simply adding a third motor. You get one Maximus drive unit at the front axle driving both front wheels through a differential, and two Maximus drive units at the rear axle with one motor dedicated to each rear wheel independently. This configuration provides several unique advantages beyond just overwhelming power. First, you get rear-biased power distribution. With two motors at the rear versus one at the front, the R2 naturally sends more power rearward. This provides a sportier, more engaging driving feel while still maintaining all-wheel traction advantages. The vehicle feels more agile, more willing to rotate into corners, more responsive to steering inputs. It's the power distribution that enthusiast drivers prefer. Second, you gain true rear torque vectoring. Those two independent rear motors can send different amounts of torque to the left and right rear wheels, enabling sophisticated vehicle dynamics that fundamentally change how the R2 handles. The system can rotate the vehicle more aggressively into corners by sending more power to the outside rear wheel. It can provide exceptional traction on mixed surface conditions where one wheel has grip and the other doesn't, by precisely controlling power to each wheel. It can even enhance stability during aggressive maneuvers by using torque vectoring to counteract unwanted yaw, or even enable drift modes and other performance features where controlled oversteer becomes a feature rather than something the stability system fights to prevent. Third, you get absolutely massive power delivery. While specific horsepower figures haven't been officially announced, community speculation based on Maximus motor sizing suggests the tri